I don't think it's French. It could be. I don't know. But how many of you have seen this before or have worked with it, know how it works?
Well, you did it. You used it with us last time too.
Did I?
Yeah.
I don't think so. This is the first time I've shown you guys a burette. Maybe you've seen it before in other places or seen it around in the lab. But essentially what a burette is it measures a quantitative amount of solution. So if you can see all these etchings on the actual burette. This is a 50 milliliter burette. And because of how the etchings are spaced out, we can read this to 2 decimal places. So it's very quantitative. And that's really important when we're doing titrations because we are using a standard solution in the burette, and the standard solution is the solution that we know the concentration of. So when we know the concentration of our solution, this is what's going to help us figure out the concentration of our unknown. We don't know the concentration of this, but if we know the concentration of one, we can use the molar ratios to figure out the concentration of our second one. So you will be doing this as a lab, I think probably after spring break. So I'll just go over the techniques of how to use a burette and just the procedures you should use when you're working with titrations. The first thing that we have to do before we start anything is we have to clean our burette. And I already washed this out with soap and water. It's nice and clean. However, there might still be droplets of water or dust or debris in our burette. And it's very important to not have any water, any other solution in our burette. So what we're going to do is we're going to coat the inside of our burette with the solution that we're using. So my standard solution is my 1 molar sodium hydroxide. And I'm just going to take a little bit of sodium hydroxide and use it to coat the inside of my burette. So the way this works is I'm just going to tilt it a little bit until it reaches the front of the burette and just rotate it. So you can see I'm rotating the whole burette and some of it's kind of spilling out, but I have to make sure the whole thing gets coated. Why do you think this would be important? I cleaned it with soap and water. Maybe there's a few droplets of water. Why would that be a problem when I'm doing a titration?
Changes the pH.
Say that again?
Changes the pH.
Yeah, it changes the pH. So when the pH of something is changing, what else is changing? The concentration, exactly. The concentration of my standard solution is changing. And we have to know this in order to figure out our unknown. So that's something that's very important. And I also want to make sure that it runs through the actual burette itself. And so when the nozzle is parallel to the burette, we have flow. And then when it's perpendicular, it stops. I'm just going to run the whole thing through. You want to make sure there's no air bubbles either. And so we've run it through. Now it's ready to be filled up with our actual solution. So I'm going to do that as well. And when you guys do this in your lab, it's best to do it over a sink. Because I've had it, I've done it myself, is that when I'm filling up the burette, I'll accidentally leave the nozzle open, and as soon as I put stuff in, it's going to start coming out the bottom. So it's a good idea to keep something underneath your burette, or make sure you do it over top of the sink. That way you won't have any, 1 molar hydroxide kind of on the floor, on your feet or anything. So we've got it filled, but we've got a bit of an air bubble here, so I'm going to get rid of that. I don't want any air bubbles in my burette because the readings are going to include that air. So we want to make sure it's all filled with solution. Okay, so I'm going to need someone tall to do the reading of the meniscus. Did you want to come up? Yeah, you look tall.
Yeah, sure.
Do it. You can read. We're going to start with what's our start volume?
Should we on the other side?
Oh yeah, come up here. That way you'll be at least closer to eye level than I am.
It's 5.9. Wait, sorry. If I'm the top or...
No. See, actually, that's a good point.
Okay, so that means you minus that from here, I'm guessing.
That's actually a very good point. You don't, but I'm glad you brought that up because I did a titration lab with my grade 11s, and that's exactly what they said. The first thing they said was, oh, my burette's broken because my numbers are backwards. It says 50 on the bottom and it says 0 on the top. The reason for that is, no, your burette's not broken. The reason for that is because a burette is used to measure the volume of something that you're going to add to something else. So if it reads 0, that means I've added 0 to my solution so far. And if I add 5 mils, it's going to read 5 mils. So that's what your reading is. Your reading is how much you've added so far. So what you want to read is, it's going to say 4 point something is what you're going to start at.
Okay, yeah. So it's 4.1.
So you can read it to 2 decimal places is the other.
Yeah, if I'm
Because
more like 4.15.
4.15, okay, we'll go with it. 4.15 milliliters. This is our start volume. Thank you. If you want to stay up and have a good view, that's fine. But you're welcome to. Okay, well the 4.15 mils is our start volume. And if I added 10 milliliters, what's my end volume going to be? Say it. Yeah, exactly. When I add 10 milliliters, it's going to read 14.15 milliliters. Does everyone see that? So the difference between our end volume and our start volume is the volume that we've added to our unknown. So that's something that's really important, is make sure you always write down your start volume, and then we'll also make sure to write down our end volume as well. So the end volume. I have an unknown solution of H2SO4, so we have acid in here. When I add base, my indicator is going to turn pink. So I'm going to start adding some base right now. And for those of you who are close, you can kind of see it'll turn pink. When I add it, I'll just let it sit as it's being added. You can see a little bit of pink color kind of forming. On that note, why do you think I put a paper towel underneath my flask? Exactly. Not just to wipe up any spills, but also just so you can see the actual drastic color change. If I had it against black, I wouldn't be able to see it as well. So that's another thing you want to note when you're doing your titration. Make sure there's something white underneath. What's another thing that I'm doing with my flask? Spinning, yeah, stirring. I'm mixing it. Because if I just let it sit, it won't mix. You can see a bunch of pink is already formed, and I've had students just be like, oh, I'm there, the solution is all pink. But as soon as you stir it, that's going to go away. So you have to make sure you're always stirring with your solution as well. So what's one thing that's different now than what was happening before when I first started adding solution? When I first started adding solution, how bright was the pink?
Barely noticeable.
Yeah, it was barely noticeable. There was hardly any pink color. But now that I've added quite a bit, you can see the pink color lasts quite a bit longer, and I have to stir it a little bit harder to get rid of it. That's telling me that the equivalence point is getting closer. We're not quite there yet, but we're getting closer. So this is a good point to slow down my titration. And I've also got a water bottle here. And this is going to help me take any solution that's on the side of my flask and any solution that's on the tip of my burette. I can take it off with the water bottle. So if I drip maybe even half a drip, you can still see there's a big droplet on the bottom of my burette. That's not in my solution, but it still counts in my volume. So I'm going to use my water bottle to just wash the side of my flask. We'll mix it up some more.
Will that affect the...
That's a good question. Will that affect the concentration? You know what? It won't, because what we're reacting here is the number of moles that are in the solution. So when I add more water, the number of moles doesn't change. So we're actually reacting moles and moles, not volume and volume. So that's something to keep in mind as well, that once you know the concentration of this, or once you know how much you've already added, it's okay if you add more water. So I'm just going to slow down the flow. So it's dripping, because I know we're getting super close, but we're not quite there yet. So I'd recommend before you start your titration is get comfortable with the flow of your burette. When I first started, it was flowing super fast, and so I was comfortable letting it flow fast, but now I want to slow down, so I want to make sure I know how to get it so it drips as well. Oh, we're getting close. Did you see that? Whoa, it's gone. It was super close. We weren't quite there yet, though. So I think for the next thing, I'm just going to add half a drop. Just let it kind of form a droplet, but not quite drop. And then I'll wash that down with my water. And I think that should be good. Yeah. I think we're there. So if I just let that sit for like maybe 30 seconds, it might disappear, but I think we've reached the equivalence point here. So can everyone see the color change? So there was no color before, but now that we've reached the equivalence point, it's nice and light pink.
Magenta.
Yeah, magenta. Nice. So this is what you're looking for when you reach an equivalence point in a solution. So if I added too much, well, let's make a reading right now before we forget. Did you want to do the reading as well?
Sure.
Where are we ending? Let's turn it around so you can remember.
So right now, so you're reading from the top down.
Mm-hmm.
It's going to be 31.25.
31.25. This is our end volume.
So
Where is it?
It's at here.
Yes.
Alright, this
Oh, there it
Does
is.
give you the
Oh.
volume of the solution,
Alright.
right?
Oh.
It's just
Can't read it.
way
Oh, well.
of finding.
What it tells you, from this, I can figure out the volume of solution that I added.
Yeah, because 4.15 was the actual volume of the whole solution.
No. That's where you started. So if you take this, subtract this, that'll tell you how much you actually added.
And when you added the water in that solution, doesn't the water react with any of the ions or reactants?
No,
I mean,
if you remember, does water dissociate into acid and base? Does it affect the pH of a solution?
Well, yeah, if you add an acid in water, then it will form hydronium ions, right?
Mm-hmm.
So right now we have acids and bases, and we are not actually at the equivalence point.
Yeah.
So wouldn't that matter when we add water?
No, that won't matter, because the reaction is happening between the strong acid and the strong
Oh, it's a strong acid.
base.
So.
Yeah, it's a strong acid, strong base. It's not a weak, for that, it still wouldn't matter if it was a weak acid or a weak base though. Because we're not adding a whole amount, and it's already in solution for it to, because as soon as you add because when you titrate a weak acid, you're going to be using a strong base.
Okay.
And so when you add a strong base to a weak acid, it's going to react right away. So the water won't have an effect on that. But that's a good question. For this one, we used strong acid, strong base, so it won't have an effect either. So on that note, we know what our concentration of our standard solution is, and now we know our volume of standard solution. Can we figure out the number of moles of sulfuric acid that's in our flask? Yeah, let's try that. Why don't you guys have a seat and we'll punch some numbers and figure that out.